So I guess since we're a few minutes after, we can go ahead and get started. If for some reason my mic drops out or somebody can't hear me or y'all can't hear me, just add a message or something to the Slack or to the chat and just give me an indication. So first off, this is an introduction to Python. I had a few people on Twitter ask me more of just like an intro of, hey, how do I get started with this, right? So I think Dawn Anderson said it best, is that she was just looking for more of a whistle-stop tour of Python, just to kind of get their mind wrapped around about what it was, how to install it, and just an introduction to some core concepts. So that's what this will cover. In addition, I'd love to do some more training on Python with maybe Hamlet, Paul, Shapiro, and get into some more advanced topics. Stay tuned for that. I've already talked to Hamlet, and I think he's interested in doing a second one. So stay tuned for that. But this is an intro, so we're not going to go over anything too advanced here. About me, I'm J.R. Oakes. I'm the Senior Technical Director at Adapt. I do a lot of our research. I'm a big meetup organizer, conference organizer. I spend my weekends hacking machine learning algorithms. I write as I have something to write about on several different publications. And a little known fact is that for 10 years, I was an architectural glass artist and designer, and then transitioned into development and then technical SEO. So agenda for this call is installing Anaconda, launching Jupyter Labs, understanding some of the basic elements, including lists, dictionaries, functions, some of the popular libraries, and then put together a toy notebook that everyone can play with. And I'll send out not only this video, but also a link to the toy notebook so everybody on the call can play around with it. First thing is installing Anaconda. Anaconda is a repo that essentially bundles everything that you need to have to run Python and to run Jupyter notebooks, as well as Spider. They handle a lot of the problems, cross OS problems that Windows users have, and they make installing a lot of libraries easy, where you would spend hours on Stack Overflow trying to install a certain library that has a dependency for another OS. They already have that worked out so that when you're installing libraries through Anaconda, a lot of those issues are worked out for you. So I've found this to be a much easier way to get up to speed with just installing and getting to work on Python. I'm going to kind of skip back and forth between this and the browser just to show you guys some stuff. And if anybody wants to stop and ask a question at a certain point, please feel free to interrupt. This should be collaborative. For Anaconda, you essentially pick whichever version you want. I would strongly recommend going Python 3.7, just because almost every major library is they still are backward compatible to 2.7, but a lot of most everything important is working on 3.6 and 3.7 for Python. Python 2.7 is an older version that a lot of data scientists started on and used, so there's a lot of code out there. There are some breaking differences that are outside of the scope of this talk to talk about, but as an intro, I would start with 3.7. You're going to have to learn a few things like print statements. That is a small change between Python 3 and 7. I mean 3 and 2. That's kind of a pain in the butt if you're using an older Python script. But yeah, start with 3.7. Also, if you know you have a 64-bit system, I would install that. It's just going to be a bit faster. Most are, I think, I don't even know if they even make 32-bit systems anymore. So anyway, once you install it, this is what Anaconda looks like here. So you have home, and you have a lot of kind of pre-built tools here that do pretty much whatever you need. You have everything from Jupyter Lab, notebooks. You can install R. Spider is a pretty well-known IDE for Python. And then you have some VS Code. This is where I spend like 90% of my time here with Jupyter Lab, and I'll go through that. Python in general and with Anaconda has a construct called environments, and essentially what environments do is let you kind of segment installations based on the version of Python that you're using, as well as what types of libraries are installed in that distribution. So you can see here I have like a base environment that has Python 3.6. I have another machine learning environment here that's called PyTorch that has Python 3.7. It has a library called PyTorch and a lot of different machine learning libraries installed on it. And then I have another library environment here called DBT. This is a good habit to get into, to create different environments for different needs, just because you can run into compatibility issues with different plugins or different libraries. So kind of containerizing the environments by the use that you're using helps with that. The learning community and stuff, I don't use most any of that. Most everything is just right here with Jupyter Lab, or either using the Python code. Go back. Okay, so that's the interface for Navigator. Let's do. Okay, another thing with Anaconda is Anaconda prompt. So you can see here that if you come to your search bar and type in Anaconda, you'll see Anaconda prompt. And when you click on that, this is a command line. It's called a command line. And essentially you can access Python directly from that. So I can come here and say print hello world, and I've run a command and I've actually programmed something in Python. But those are normally the two ways that you'll interact with Anaconda. And I'll get on to Jupyter Lab in a second. Here's another example here where I've showed that the base environment is the active environment. I type in activate PyTorch, which is the command to activate a different environment in the Anaconda prompt. It changes to PyTorch. That is the same environments that were listed here. Oh. And then the same thing, I typed Python, and then you can run the command Python hello world. So you're programming in Python there. A lot of this is going to focus on Jupyter Lab because I feel like Jupyter Lab is a really good way. Let me see. Do you see chat? I see a notification in chat, but I don't see an actual chat box. Okay. Oh, that's a good question. I don't know the answer to that. To be honest with you, I try to keep environment names. Jake asked, does the environment name matter, or is there anything we need to know? I've never come into that. I try to keep them as short as possible, and descriptive. So I don't know the answer to that. Most of the time, it's going to be Python 2, Python 3, like I call it PyTorch, DBT. So I try to do it more on keeping it as short as possible, just so I don't have to type out as much when I'm switching environments. All right. Okay, so Jupyter Lab. So all you have to do once you've installed Anaconda to get access to Jupyter Lab is, and I'll do a little demo here, is actually click on this interface for Anaconda, go home, and then you essentially, once you install this, this will say install. Once you install Anaconda, this will stay install. So you essentially have to say install, it'll run for a second, and then you click launch. And when you launch, you'll get something that looks like this. It normally runs on port 8888 of your browser, and localhost is your own machine. Essentially what it does, what Jupyter is a small web application that's running on your computer that puts out a UX that you can type either code into it, or you can type annotations right here. And then once you run one of these cells, it essentially sends the content of this code to Python. Python executes it and then sends back the output here. It's a really, really good tool. And Jupyter Lab and Jupyter in general with notebooks has made sharing code and commenting and editing code and having it transferable from one person to the other really easy, because you can not just, sometimes you read a lot of code and it's really hard to trace and follow, but if somebody spent the time to go through and say, okay, this is what this does, right? This is what this next section does. This is what you need to put here. It's more collaborative, and it's also easier to follow the code. So you can see here in this example that the top part of this is a tool I made maybe a couple of years ago. The top part here, and we share these internally, the top part here is just more standard markup where I just go through and explain everything, right? These are the libraries that you need to have installed. This is what this next section is going to do. Control plus enter executes the cells. So I kind of explain everything in this cell. And then this is what I actually code, which is sent to run in Python and sent back. One other thing about Jupyter Lab is that when you're installing it locally, you can see in my lab here that when I click on the home button, it goes to my repo of a ton of different Python projects, which are a lot. It's really good to specify a start screen for Jupyter. so that you don't have to keep navigating through your entire drive every time you want to find a notebook. And after you install Python and then install Jupyter, after you install Anaconda and then you install Jupyter Lab through the interface, you can open up the Anaconda prompt that I showed you before. You type in Jupyter notebook -- generate - config, and that'll tell you if there's already been a config file already added for your notebooks. So in this case, I already have a config file, so I don't want to override it. But if you're just installing this is just a simple hack where you can essentially navigate and find this file location here. And then you can edit that file. And around line 201, you just put the start directory of your whatever project folder that you want, right? And then once you restart Jupyter, it should open up to this project directory. So you just keep everything in one place and you're not having to navigate your entire C drive. One other thing, and this is a tip that I got from Hamlet, who's on. Hey, Hamlet. Google Colab is essentially Jupyter notebooks hosted on Google Cloud. And they're free. They contain GPUs, CPUs, so you can run them for all different types of purposes. And one of the things that I do to learn and to help train myself on different libraries is to look and see what other people have done, right? So you can see in this, if you don't want to go through the entire process of installing Anaconda, installing Python, installing Jupyter on your local computer and getting that all set up, and you just want to play with a Jupyter notebook, you can go and find, like, here's a Google Language API intro. The IPYNB means notebook. That's the extension for IPython notebooks. You can do a search on GitHub, find a notebook that somebody else has already put together. And if you just take off GitHub and instead slap collab.research.google.com/GitHub, replacing this domain, it automatically will load it up on Collab. So essentially this pulls it directly from GitHub, loads it up on Collab, and you can actually start playing with it there. So that's the 0 to 5 second way to get started in Python and accessing it with Jupyter. Depending upon how much you want to do with it, I find working locally with Jupyter and Python a lot easier for me, and I do most of the work as far as training models or things where I have access to a free GPU on Collab. One of the problems with Collab and why it's good for like an intro or just to kind of get used to it is the persistence of data here. So if you run a notebook on here that generates some files, then once that session is over, Google kills that virtual machine and those files are lost. So that's one reason to work local, so that you're saving it actually there on your machine. When you come back to it in 2 weeks or whatever, the files that you generated are still there. There are some ways that you can work around that in Collab, but again, that's a little beyond the scope of this. All right, does anybody have any questions so far? Still don't, okay. Well, we'll jump into some basic elements with Python. Essentially, these are the core things that you need to know within Python that can get you to an understanding of being able to read most of the code that's out there. that's at least not more of the esoteric machine learning code and code specific to individual libraries. If you know these things right here, you can code something useful in Python. So first is a string. If you get into the Python communities with different codecs and different encodings and byte strings, it's a really messy world to try to encode, hundreds or thousands of different languages into kind of a single codec. So that's a big rabbit hole to go into. Essentially, a string is a set of text that you're assigning to some variable. This is also something that will, if you do any kind of scraping of websites with Python, that you'll be on Stack Overflow a lot, because there'll be different encodings that you're getting that is pulling from other sites that are not compatible. So you'll spend a lot of, expect doing any kind of scraping with strings or any type of crawling, that you're going to be on Stack Overflow a lot, trying to solve different encoding errors. Every developer is. Lists is just a series of items stored sort of an array. I would think of this as like a PHP array, right? It has a definite order to it, and then you can add and remove items. You can get the length of the list, how many items are in the list. But I typically think of this as an array. A set is just a unique list, right? So this is very common where I might have a listing of URLs and I want to only show unique URLs, right? So I can take the list of URLs and then wrap it in a set and run that, and then it'll give me only the unique values that are found in the list. That's a very useful tool. Dictionaries are just key value pairs, right? Where you have some key that you want to look up and you want to return value. So it makes sense that it's a dictionary, right? The term dictionary. And you can see here, yeah, so I'm saying link PR equals integer 5, and then I'm asking for the fifth or the number 5 or the element that has the key 5 from my IM dictionary. So if I print this function, then it's going to pull key 5, which is gimme, and then you can see here my reaction to PR5 link is gimme. So this is actually called indexing, where this is the given dictionary, and then this is what key that you want to look up and return the value of in this dictionary. Should say with lists as well, that the annotation, here, I'll pull this up. With lists as well, you can also key on, like I want the first element of the list, and then it'll return this element here. All items in a list are start with 0. So 0 would return actually the first item in the list. 1 returns the second item in a list, and so on. Whenever sets, for loops are pretty common, and you can iterate for loops on dictionaries, you can iterate them on lists. So essentially it's for something in the list, right? So this says for essentially each item in the list, do this, right? where it assigns the I or whatever variable you put here each item. For loops are very common. The same thing here. You can see that for I in dictionary, this actually becomes the key value for the for loop for the dictionary. So you can see here that assigning this the key, it prints the key, and then here I look up the value in the dictionary based on the given key. List comprehension is one of my favorite things within Python because it just allows us to shorten the amount of code that we're writing. So essentially, you can wrap anything in. This is the annotation for a list here, the square brackets, and you can put different for iterators in these brackets. So for here, I could say what this is saying is for each item in the list, in the IAM list, give it and pull the corresponding dictionary value based on that item. So you can see what the output becomes here, which becomes a list. But there's a lot of instances where you could say, this is commonly used in NLP, where you say, you know, for each word in this string, add the word to the list if it's not in this other list of stop words. So you'll see this a lot. And when you have see if for loop wrapped within square brackets, it's called list comprehension. So that can help you in your research process when you're having issues with a certain set of code. The other one is Lambda functions, which essentially a Lambda function is a function that's given some value X, and then you write some simple script that executes on X. In this case, we actually have, we're giving it X and Y, and essentially it's returning the Yth value of X. So in this case, the dictionary that we provided earlier, we wanted to get the 9th element of that dictionary. And in this case, it's simply saying, okay, IAM dictionary is the X value, 9 is the Y value, and it's going to pull the 9th value of the dictionary X. So this is just a really easy way, or shorter form way, not to have to write something in the common function structure, and it just saves time and space and makes it more efficient, more code efficient. Another type of function is just defining a function, where you define the function name, you give parameters where that someone can give to this function, and then you put whatever code, Python code here to do some operation on the parameters given, and then this is called a return statement, where you return whatever the output of your code was. But you essentially define this function with this parameter. I'll stop here and show with functions. Nope. Yeah, functions have parameters that are positional parameters, but you can also have named parameters. That's something, I don't think it's unique to Python, but it's something that's very useful in Python. So I could also have in, sorry. So I can have a positional parameter here of num, and I can have another parameter here that has a default value of 0, right? And that's useful for cases where I want to specify that n has a default value, but if somebody wants to use the function again in some way, and n something that's important to call that function with, then they can make that change, but this assigns a default value to that. But that's named, and then or keyword-based parameters, and then positional-based parameters. Are there any good cheat sheets for encoding issues? I'll have to dig that out. And can you make a note of that, a cheat sheet for encoding issues? I've read one like a couple of months ago that went into a lot of the history of encoding from ASCII to UTF 8, UTF 14, or UTF 16, and all the different coding languages, and also the issues with each of those. I'll see if I can dig that out and send it over. Curly brace values. Jake, is this what you were talking about with curly brace values? Can you hear? I don't know if he's still on. The link is, yeah, I mean, I'm not sure what's meant by curly brace. I mean, with curly braces here, we're essentially defining a dictionary, which starting of the curly brace and then ending of the curly brace. And then the keys and the values of the dictionary are put into this annotation here, where you have the key. Yeah, you can. Feel free to can you unmute yourself?
Oh, perfect. Can you hear me?
Yeah, I hear you. Perfect.
Okay, yeah, it was in the command you put print my reaction to a PR and then the zeros and curly brace, and it looks like it's grabbing
right
a value.
here.
And I'm trying to figure out how do you know? Like, is that the first variable that you defined? It like automatically pulls in a value. How does that work?
Yeah, well, and
he's talking about format strings.
Yeah, no, I got it.
Interpolation of common strings.
Yeah, essentially here you can do either positional based strings, or you can do name based strings with the format function. So I don't even think you have to include the 0 1s here. I just do that for my own benefit, so that I can point to the positional so it's easier to read. But essentially what this does is when you print, you put your first curly brace, whatever string you want, second curly brace, and then this dot format here essentially takes the value of I, puts it in the first curly brace, and takes the value of the output of this list, and then puts the value here. So it's just a really easy way to.
So it works kind of like eval, basically.
Yeah, it's a really clean way to write strings without having to do a lot of, close parentheses plus, and then do code, and then plus, and then open parentheses, write more code. You know what I mean? It just makes the strings easier to read. Yeah, so this value is put here. This value is put here when it's printed. But you can, like you could, for example, here, say, like give, instead of 0, say item, and then for this one, say list, or not list, but list value. And then you could say item equals I, list value equals I am a list, to even, if you wanted to make it even clearer. So this supports either positional or key based or name keyword based formatting of text with values. That make sense? If anybody else has has a question, feel free to just unmute yourself and speak up. Let me say, yeah, and there's some good comments in the chat. All right, we went over functions. Okay, here are some of the main libraries that you want to become familiar with Python if you're just starting out and you're interested from an SEO standpoint. Pandas is I think the first library that I used for Python. Essentially, the way I think of Pandas is think of it like scriptable Excel, right? Where you have data tables and you can read in a CSV. Here we're calling something called head, which is a function that returns the nth number of rows from the beginning. There's another one called tail that returns the nth last rows from the end of whatever table that you've imported into it. But the nice thing about Pandas is where you may in Python have a data set of 70,000 rows of something, and you load it into Excel, and Excel starts crashing out and giving you the white spinning screen that never ends. Pandas will eat that like nothing and do all kinds of functions on it like nothing. Pandas is scriptable by column, meaning that you can do df dot URLs, and I want to see from the beginning to the 5th value of the URLs column, and that outputs here. It's really easy to sort and filter in Pandas. So in the prior data frame, I just read in a normal CSV called URLs. This is what it looks like. I can say from that data frame, show me only rows that the column position value is less than 5, and of those rows and the URLs and those and the URL column in those rows, I want to output that to a list, and then you have that information here. There's also a function that you'll learn early using Python or using Pandas called apply, where you essentially just want to apply some function to a lot of the rows, right? So in this case, I'm just trying to get the domain for a URL given the row. So here, I define a function that says, all right, if the input row, for whatever the input row is, I want to grab, for each row in the data frame, I want to pull the row URLs column and assign that to the variable URL. Of that URL string, I want to split it, which essentially breaks that URL up into different chunks based on whatever your split value is. In this case, a /. And then I want to get the third element. Keep in mind that lists, which the URL split produces, start off with the first value having an index of 0. So you always start 0, 1, 2. So I need the third value. And then based on the third value picked here, I'm going to assign a new column in each row called domain to this domain value. So you just define this real simple function, and then you call df.apply, give it this function, and then the axis here is tells it axis equals 1, tells it to apply this to each row as opposed to apply it to each column. And then you can see here, after we ran this df apply and then do df head, that it now has a nice domain added to each column. And again, if you were to apply this to 80,000 rows, it would probably take 15 seconds, 20 seconds maybe, depending upon the complexity of the function. And then you can save it to a CSV and do whatever you need to in Excel or any other tool. One other thing here, this is a quick video, but this is, I don't know if y'all can see this, but this is my normal, anything that, getting started with pretty much any kind of library in that you're interested in. GitHub is your friend. There's thousands of intro Python notebooks on there that are annotated and kind of walk you through the process. In this, it's just showing me going to GitHub. Here, I'll restart it. Searching for intro to searching for an intro to pandas. I don't know why I stopped. You can select Jupyter notebooks here. You can download, in this case, I downloaded the entire repo. Open that up, just extract that to whatever folder you have for Jupyter or Jupyter Lab, and then you can open up Jupyter Lab and then open that folder that you just saved from GitHub, and then you have an entire workflow. In this case, this is from, I think, Stanford, but this is an intro that a lot of their CS majors go through for this, and everything is annotated and explains what every cell does, and you can execute it and see the output. So that's a really cool hack for just getting used to certain libraries. The other one is requests, which essentially with requests, you're importing request library. You would do the same with pandas, import pandas, but here we're going to import requests. And then requests, essentially you say request.get, and then you give it a URL, right? And then it'll return back the response information, which you can do stuff with. You can see in this example here, we've defined a user agent header, which is a dictionary of the user agent value and then what the actual user agent string is. And then we're passing that to the request function here as headers equals headers. But you don't have to do that. I do that because a lot of sites tend to see the default headers from the request library as kind of bad bot activity, and putting in either Google or putting in like a Chrome user agent tends to overcome that a lot. But there's some example code here. But essentially requests is used to load URLs, pull the text from the URL. It has built-in features for parsing JSON from URL, so it's really easy to interact with APIs. Also, it's really easy to just do ad hoc content scrapes from websites. The last one, I think, is Beautiful Soup, which Beautiful Soup is almost like just jQuery for Python. It essentially lets you extract, get content from requests. Like the request library loads content from a site. You can see here that we got the content from the site. It's stored in the r.content, which we assign to HTML. We then load up Beautiful Soup on the HTML, and here I have a for loop which says for each tag in the parsed HTML, I want to find every A, and then I want to do stuff on that. So this actually parses the actual DOM tree of the HTML that comes back and lets you do things like target elements, scrape elements, get the title, get the description, get whatever you need to out of web pages. So from an SEO standpoint and scraping or pulling data from sites, this is one you really need to know. The last one is Google API Client, which for access to Search Console and AdWords data and analytics data, that's a really good one to learn. There's a number of examples online, and I think I have a few online that have some pre-built code that you can workflow, but I would say this is more of an advanced after you've gotten used to some of the more fundamental items. I'm not going to go through that. Okay, I just want to show one quick workflow because this is something that I was able, and we have just a few more minutes, and then I'll ask for any other questions. Nope. Here we go. Okay. So this is the toy example notebook that I went through in that call. So I'll send this to everybody on the call, but you can run each of these in Python or in Jupyter. It's really easy. You hit Control Enter, and it runs whatever is in this cell to Python and returns back values. But here's a really simple call that I made. This is actually using something called, this uses request, it uses Beautiful Soup. And then I've created something that's a class, a scraper class here, that you essentially give it a website URL. You give it a website URL, and then it extracts data from that URL. In this case, we're giving it news.google.com and asking it to pull all of the A links out of that, get the href, and then we're going to extract something from that URL. So in this case, this is useful. Like if we wanted to say, what's the distribution of the type of content on Google News, right? So with this really simple code here, request and Beautiful Soup, I'm able to just give it the news.google.com URL. It requests that information, and then it shows me all the URLs that match either articles, publications, stories, topics, or for you, which are some of the paths for Google News. So you can easily scrape, cobble together, 20 lines of code, run it, and then there's a library called matplotlib, which essentially does a lot of the coding or plotting functionality for, it's the most popular library for plotting information in Python. It's also built into Pandas. But you can see here that I extract all the URLs for articles, publications, stories, topics, and for you. I just essentially print out the occurrences of those on the main Google News page, which you can see that the gross majority are articles, They have some labeled as publications, and then topics and stories. Topics is interesting. I've never seen that one before. I just added that one today. But that's just a really ad hoc analysis for that. So with that, I'll leave the last 5 minutes if there's any questions from anybody. Feel free to unmute if you are.
Hey, JR, this is Noah.
Hey, Noah, what's up, man?
I've been trying to get your shingles or shingling repo to work, and it keeps erroring out. And
what's the error?
can I share my screen?
Yeah.
Okay, cool. I've tried it a whole bunch of different ways, and I keep getting the same thing. Give me a sec here. I have a whole bunch of terminals open. Let me close them all so you can see them. Terminate.
Hey, while he's pulling that up.
Pull that up. Keep talking.
I noticed this is being recorded. Are you going to share the recording back out?
I am.
Thank you.
Yeah.
So basically the error that I'm getting is one where, open with Python. Okay. Where it keeps saying that the key for body content 1 is throwing an error, and it's saying that there's stuff wrong in pandas. You know how in your example run it says to have the column of all internal is body content 1? Yeah. I named the extraction to match your pattern exactly, and it kept saying key error. And if other people have questions, I'll get it to run again, and then I'll show you the error, just so I don't hold us up.
Okay.
So let's have me not share, and then when I get it to run, I'll come back to it. If you guys are okay with that. I don't want to hold anybody up.
Well, maybe we can do a screen share after this.
Yeah, that's fine. Yeah, that's fine, if you have time.
Yeah, but anybody else have any questions? If not, I guess we can call it a day. And I appreciate you guys jumping on. Hamlet, you up for the more advanced one coming up?
Well, I don't know if it's gonna be more advanced than this one, because you're blowing people's mind with this. You're raising the bar too high for me.
Whatever.
We're climbing. So this is great, guys. This is really awesome. I'm so excited to see all this Python stuff going around in the community. It's just amazing. I'm just giving my finishing touches to my article for Search Engine Journal. Should be fun for this Friday.
Cool.
So excited.
Awesome, man. Well, thanks for joining. Noah, I'll follow up with you after. Thank you, guys. I'll give you your 2 minutes back. But thanks for joining.
Thanks to you. You're best. You're the best, JR. Thank you.
Thanks so much for taking the time to teach us. Thank you.
Yeah, no problem. All right. Bye.